Hello everyone, I'm John Everest and this is the fourth and I'm pretty sure final short video on high dynamic range image for lighting analysis. And in previous videos I've sort of contrasted high dynamic range and low dynamic range images, and I've shown like sort of some of the data we can extract from a high dynamic range image to explore the space, and I've just talked about how we can then start to sort of add high dynamic range images together to simulate sort of switching functions and sort of explore options without actually having to do time-consuming ray trace calculations. And now I'm just going to tell you how we can take that a step further, in that we don't have to add sort of 50%. We don't have to sort of just sort of add images together in a binary fashion. We can sort of combine 50% of one image with 100% or 20% or 90% of another image. So we are in effect simulating dimming functions, or glazing transparency, or transparencies of our blinds, or a coarse idea of window fenestrations. So here's the same image, and I think I don't know, maybe it was the second presentation I did. I was sort of looking at exploring what would happen if we switched all the lights off at the back of the classroom. How would that look? And we'd concluded that it's simply too dark at the back of the classroom, and it would be better to dim the lights rather than switch them. So let's explore that concept. So I can add all these images together, but with only 5% of the rear ones at the back, then 5% as well of the middle row, and 5% of the front row, and we'll drop the side down lights down to 5% as well. So very quickly I've created that image, and we now have a good idea of how it would look, and we can also just perform exactly the same analysis. And perhaps that's saying to us, you know what, 5%, that's probably, maybe we need 10%. And the beauty of this is we can explore like that. So we can go back to our commissioning engineers, and and we can say, assume you're going to be dimming these areas to 10%. That's a starting point. Obviously, best test is get in the room and see how it is. But but at design stage, we can start to understand our energy loads if we know that's what we're going to dim down to. And also finally for fun, although there is you could have a real project application for this, is if you were looking to do some lit effects or architectural lighting. We don't have to just simply add the white light with the white light. In Radiance it does keep the lit data for the red, blue and green color channels isolated, so we can add the portions that we want. I use the term accurately in commas, just because in the real world it's not a sort of a it's not a clean split from red, blue, green. There's a sort of many sort of chromas of color. But all the same, we can take our classroom and then we can just use colored lights and add them together. And if we don't like a color, I had a play around, and it was just lightning fast just to find a palette of colors that I did like. Or if I wanted to sort of simulate an animation of shifting through different colors, it's going to be so fast to do that. Never seen a classroom lit like that, but well, it's just a technical exercise, really, isn't it? To show you what's possible. So just to wrap this up, let me labour the points I would like you to take away. Just be aware that a JPEG image it does very well what it was designed to do, and that was capture visual data in a very efficient, compressed way. But it is not capturing even close the full lit luminous range of an environment. A high dynamic range image can, although you cannot actually sort of view a raw high dynamic range image. You will need to tone map it, that is, sort of squash that lit data into a range that your monitor will be able to display to you. So with an RGB image, we can accurately capture that luminous data, and we can start to think of the image as a calculation grid of sorts. So if we want to start to sort of get false color images and stuff, we do not have to recalculate the scene. It is all one calculation, and it all sits in the scene waiting for us. And in this last presentation and the one before, we just looked at how you can explore some different workflows. And if you have If you want to sort of very rapidly explore different lit scenes and get some physically accurate data, here's a workflow you might want to consider. I think it's going to be it's like quite an exotic method, isn't it? You're not going to be using it day to day, but it's a way of working that you can sort of keep in your back pocket. And I find projects come up from time to time where this is useful. It's useful to do it, and you don't sort of you don't bottleneck the project with long calculation times. You can very quickly just ask a question and answer it immediately. So I hope that's useful, everyone. And oh, actually, I think there is. Yes, there was. Yeah, I just wanted to let you all know. All this stuff's free. So Radiance, that's the most important one. Radiance is amazing and it's free. Difficult to learn, but it's free. You need to actually Radiance. You don't really make your model in Radiance. You can, but it's much easier if you use a different modeler. There's Radiance tools for Dynamo, which I made. That's you can sort of you can use some of those functions to like organize your model to go into Radiance. HDR scope, you can use that to make your false colored images. I do it straight from Radiance, but HDR scope will get you to the same place. Luminance HDR will display high dynamic range images, so you don't have to sort of subscribe to like Photoshop or anything like that. That one's free. Image Magic, you can use that to tile off your images. If you start to get to sort of like bigger packages and you need to sort of like hour by hour analysis, Image Magic will do the heavy lifting for you. I got my complex models from Turbo Squid. I've no interest in making chairs and tables, and I like to do my modeling in the awesome Rhino 3D and Grasshopper. That's free for like 90 days, so you could get yourself started. But whatever you like, 3ds Max or Maya or whatever there is out there these days, it all gets converted into Radiance geometry, so doesn't really matter. Okay, so off you go and have some fun. Good luck with that. We'll see you later.